Hello guys, so in this lecture we are going to learn about the complement. The complement is a fundamental concept in digital logic design which is mainly used for the subtraction purpose. So when we need to perform a subtraction, we usually do the complement and add them with the number in order to get the subtraction. So that is the important concept, the complement, and which we are going to see in this lecture. So let us first understand the different types of complements. So mainly the complements are divided into two types of complement. One is a diminished radix complement. So if our base system is R, then the diminished radix complement is called as a R minus 1's complement. And the another one is a radix complement. So if our base system is R, then the radix complement is called as a R's complement. So here this R indicates the radix, or in another terms we can call it as a base also. So if our system is a base system is 2, or we can say the radix is 2, so we can say that the R minus 1, that means 2 minus 1, ultimately diminished radix complement is called as a 1's complement, and the radix complement is a 2's complement. Okay, so that we will see the different number system and their diminished radix complement as well as the radix complement. So let us start with this binary number system where the radix, or we can say the value of R, is 2. So as I already told you previously, the diminished radix complement is ultimately R minus 1. So here the R is having a value 2. So R minus 1, so that is called as a 1's complement, is called as a diminished radix complement when we have binary system. And the radix complement is ultimately the R's complement. And the R is having a value 2. So radix complement is called as a 2's complement. Okay, so this is a diminished radix complement, the radix complement in terms of in case of the binary system. Now let us take an example that how we can get the diminished radix complement when the input number is binary. So since this is a binary number, the maximum possible value or maximum possible digit in this number is 1. It cannot go beyond 1 because we have a binary system where the base is 2. Okay, now we want to perform the diminished radix complement. So in the binary system it is called as a 1's complement. So in order to get the 1's complement of this number, what we usually do, we just flip the bit that 1 to 0 and 0 to 1. Okay, so in our case the 1's complement will be just the flipping of the bits whatever they present in the input. So here we can say the 1 is flipped to 0, 0 is flipped to 1, 1 is flipped to 0, 0 is flipped to 1, and so on. Okay, so the input number is this one, and the 1's complement or the diminished radix complement is 0 1 0 1 1 0 1. So that is the diminished radix complement. Now the radix complement of any number in any number system can be obtained by first of all getting the diminished radix complement and by adding 1. Okay, so let us assume that the input number remains same, that is 1 0 1 0 0 1 0. So in order to get the radix complement, okay, or what we first of all do, first of all we get the diminished radix complement of the number. Okay, so which we have already calculated over here, so we just copy that one, and then after we will simply add 1. Okay, so by that way we will get the radix complement. So here 1 plus 1 is 0 with carry 1. Okay, so that carry 1 will be appear over here, and then the rest of the number will appear as it is. So this 2's complement, or we can say the radix complement of the input number 1 0 1 0 0 1 0 will be 0 1 0 1 1 1 0. So this is a typical example of a binary system and how to obtain the diminished radix as well as the radix complement. Now we will see the other number system such as the decimal and octal, decimal and hexadecimal. Okay, so now we will move to the number system, octal system. So in the octal system, the radix value, or we can say the base value, is 8. Okay, so the diminished radix complement is r minus 1. So that means the 7th complement represents our diminished radix complement, and the r, that means the 8th complement, will represent our radix complement. So now let us take an example that the input value is 457. Okay, now as you can see, the highest possible number is 7. So in our octal system, the highest possible number is 7. So all the numbers should be either less than 8 or up to 7. Okay, so 457 is a valid octal number. Now for this input, I want to find the diminished radix complement. So ultimately I need to take the 7th complement. That means I need to subtract this number from 777. Since this is a 3-digit number, so we need to write the 7 3 times, like a 777 minus 457. Okay, and by doing that we can get the value 320. Now again take a note that whatever the answer we get, that is also the octal number, and the digit has a maximum possible value is 7. So here 3 is less than or equal to 7, 2 is less than or equal to 7, or 0 is less than or equal to 7. So this is the valid octal number. Okay, now for same input number 457, we will find the radix complement. Okay, ultimately the 8th complement. So that means first of all the input number is given, we find the 7th complement, which we have already calculated over here, and we will simply add 1 to get the 8th complement. We can also say the radix complement. So this is a 321 of input number 457. Okay, so this is the radix complement. Now we move to the another number system, that is a decimal number system. So decimal number system, the number system which we use in our daily life, where the base value is 10, or we can say the radix value r is equal to 10. So r minus 1, that is the 9th complement, is our diminished radix complement, and r value, that means the 10th complement, is our radix complement. Okay, so now we take the same number as the input, which is a valid decimal number 457. Okay, so now the 9th complement, since this is a 3-digit number, so in a 9th complement we subtract the input value from all the 9. So 3-digit number, so we write 3 times 9 and we subtract the 457. So ultimately we get the 542. Okay, so this 542 is a diminished radix complement of input 457 when the number system is decimal. So similarly, what we can do, first of all, calculate the 9th complement and we add 1. So by that way we can get the 10th complement. So in our case, the 543 is a radix complement of input number 457. Okay, we now change the another number system, that is a hexadecimal number system. Okay, so in the hexadecimal number system, r minus 1, that is a 15th complement, is called as a diminished radix complement, and r value is 16. So 16th complement is our radix complement. So we consider the same number 457 as input. So 15th complement, so this a 3-digit number, so we subtract the 3 times from 15. So in a hexadecimal system, the 15 can be represented as f. Okay, so we write the 3 times f minus 457, and by that way we can get the BA8. So this BA8 is written in a hexadecimal system. Okay, so that is the diminished radix complement of input value 457. Similarly, if you want to find the radix complement of input number 457, first of all we calculate the 15th complement, that is BA8 we have already obtained. We will add the 1, so we can get the BA9, which is the 16th complement, or we can say the radix complement of input number 457. So this is all the information about the diminished radix complement and the radix complement with a sample example. In the subsequent videos we will Try to go for the question and answers of complementing the given number in a diminished radix as well as the radix complement. Thank you.